Hello everyone. Thank you very much for your interest in our work. The title of our paper is Relaxing Contrastiveness in Multimodal Representation Learning. This work was done when all the authors were affiliated with the AWS AI Labs at Amazon. For the motivation of this work, multimodal representation learning for image and text pairs can improve the usability and generalizability of the learned semantic concepts. However, recent work like CLIP and CONVERT by default use the InfoNCE loss. Our question is, can we design a better contrastive learning loss function that allows more flexibility in the learned embedding space? To this end, we proposed the Relaxed Contrastive loss, or ReCo. In comparison to the widely used InfoNCE loss, ReCo does not penalize negative pairs whose embedding vectors are already orthogonal or negatively correlated, which allows more flexibility in the optimized multimodal embedding space. In terms of implementation, ReCo acts as a direct replacement of the InfoNCE loss without any modification to the model architecture or training protocol. Specifically, after mapping the image and text into the embedding vectors using corresponding encoders, our ReCo loss maximizes the cosine similarity of the diagonal terms that are positive pairs, while force the off-diagonal terms to be orthogonal or negatively correlated. For experiments, we first tested the proposed loss function on the MIMIC-CXR dataset. MIMIC-CXR dataset is a medical dataset consisting of radiology images and reports provided by doctors. As shown in this table, our proposed ReCo objective can consistently outperform the InfoNCE loss with the same model architecture and training protocol. For the ablation studies, we tested different bench size, embedding dimensions, and weights for the off-diagonal pairs. We noticed that the model is not sensitive to the embedding dimensions. We also show that ReCo can consistently outperform the InfoNCE baseline with different weight values for the negative pairs. The text-to-image and image-to-image similarity distributions are also quite different from the InfoNCE model. To demonstrate the generalizability of the loss, we also ran experiments on the Flickr 30K dataset, a dataset where each image is paired with multiple captions. We tested pre-trained CLIP, as well as CLIP models fine-tuned with InfoNCE and our ReCo loss. We show that model fine-tuned with ReCo outperforms other models in the text and image retrieval tasks. To summarize, in this work, we proposed a new multimodal pre-training objective, ReCo, that acts as a direct replacement of the widely used InfoNCE loss. As an application paper, the effectiveness of the ReCo loss was tested on MIMIC-CXR, a medical image dataset, and also the Flickr 30K dataset. Please check our paper for more details.